one we've all been waiting for? Trig word problems, right? Trig word problems. This first one, I guess the first one doesn't really classify much as a word problem. It's more along the lines of, hey, just what's the equation of what you're looking at here? So it says construct a sinusoid that comes from this picture. We have a minimum at y equals 5 and a maximum at y equals 25. So 5 and 25. And it says that the maximum happens at x equals 32. The minimum happens at x equals 0. And that is very, very important information. Because what does this span from x equals 0 to x equals 32 represent? Half of the period. Which means we actually know the length of one full period. It is, 32 times 2, 64. Cool. That's going to be needed to hold on, I just got this mouth. That is going to be information that is needed in order to find the b value, the number that sits in front of x in our function. We know a minimum, we know a maximum. That means we should be able to find the midline. If I know a minimum and maximum, where can I always find the midline? Halfway in between them. In mathematics, we call that the average. The average of 5 and 25 is 30 divided by 2, 15. There you go. Now, it's not part of the question, but I do still think it's important that you know where this midline hit is going to happen and where this midline hit is going to happen. Halfway between 0 and 32, 16. Halfway between 32 and 64 is 48. There we go. Cool. Well, if the midline's at 15 and the maximum's at 25, what's the amplitude? 10. There we go. Wow, that was a little bit more painful than I was hoping for, but yeah, we know that our amplitude is 10. We know that our midline, we've already said it, is y equals 15. We also know the length of one period. Period length is supposed to be found by doing 2 pi divided by b. Our period is 64, so we say r equals 64 is 2 pi over b. We're trying to solve for b. The way you do that algebraically is multiply both sides of this by b, but then divide by 64 to get b alone. The net result is 2 pi over 64, which reduces to pi over 32. All right. I guess the only thing we need to do now is decide on an appropriate model, sine or cosine. What do you think works better here? Cosine works fantastically. Positive cosine or negative cosine? Well, let's think about it. Cosine is supposed to start at a maximum. This starts at a minimum. So it would be negative cosine would be the best fit. Because cosine always begins at a minimum or a maximum. This one beginning at a minimum makes it a negative cosine. Is it the correct answer? Well, no, you could have chosen anything you wanted to, but this is the easiest one to use because it starts at a minimum. So our negative cosine model would be y equals negative, then the amplitude 10, cosine of, well, since it's beginning on the y-axis like the parent function is supposed to begin, there is no phase shift, so the only thing that's going to be inside these parentheses will be this pi over 32. And then midline plus 15. That's the easiest equation here. But of course, it's not the only possible equation. I mean, there's technically an infinite number of possibilities here. All you have to do is phase shift and maybe multiply by -1 or something. So just for poos and giggles, let's go ahead and get an answer in sine. I'm feeling positive sine. What would be an appropriate x value to start at for a positive sine wave? What is it? 16. Right here, our graph begins at the midline and goes up. And that's what sine does. So that would be a shift to the right 16. So another possible answer is positive, because it's positive sine wave. If it begins at the midline, it goes up. Sine of, we do have a phase shift this time, so there'll be more than just this pi over 32 in these parentheses. Since it's to the right 16, I need to say x minus 16. That is but two of an infinite number of answers. I mean, I could have started back here at negative 16 and said it was a negative sine wave. Or I could have started right here at positive 32 and called it a positive sine wave, or negative 32 and called it a positive, or cosine, called it a positive cosine wave. It really doesn't matter. You just want to be able to write it in more than one form. What do you think about that? Not too bad, right? No, Mr. Rim? Fantastic. If you could write it in a different format? Well, you never know when you're going to have a picture, and it says select all of the equations below that are this graph. Yeah, I don't know, maybe. You might not, because it might be too difficult. I don't know. Next. This one says to construct a sinusoid that has a period of pi over 5, amplitude of 6, and it goes through the point 2 comma 0. Now, it didn't mention anything about a vertical shift. So the easiest way to attack this question is just say, well, why don't we just assume there was no vertical shift? That's the easiest way to do it. So let's just assume no vertical shift. Cool. And we weren't told what part of the graph has to go through 2 comma 0. So you know what would be a really easy part to say goes through it? The beginning. Call it the quote unquote beginning of a period there. I mean, why not, right? Has an amplitude of 6. We also weren't told sine or cosine. It doesn't matter. So pick one. What do you guys want to do, sine or cosine? Sine, good, because that's what first period said also. So now at least the video will match what they said as well. So a positive sine wave will look like this. All right. We know that the period length is pi over 5. We can use that to solve for b. We know the amplitude is 6, so that goes in the front. And since we're saying no vertical shift, the midline is at 0. And this beginning point, quote unquote beginning point, was supposed to be on the y-axis. So you guys have shifted it to the right too, like that. Ta-da! I mean, really all we need is to figure out what b is, right? That's it. So the period length is 2 pi over b. And the length of our period is pi over 5. Cross multiply, because we have fraction equal fraction. If you cross multiply, you're going to get pi b equals 10 pi. B pi equals 10 pi. Because I think that makes it really obvious what b is. Divide both sides by pi, you get b equals 10. There. Now we just write an equation. You guys said sine, I drew a positive sign. Y equals amplitude sine of, the period should have started on the y-axis, but didn't. So there is a phase shift. We know that there's a 10 in front of our x. It's been shifted to the right too. And there is no vertical shift. It's finished. It's legitimately that easy. Yes, ma'am. Amplitude's always positive, but you mean how do I know if the function has a plus sign or a minus sign in front of it? Well, if you think about it, as far as sine and cosine are concerned, there's only 4 shapes. There's positive sine, there's negative sine, there's positive cosine, and then negative cosine, Looks like this. And we just need to know those 4 shapes. So based on those 4 shapes, you know if you're dealing with positive sine, negative cosine, positive cosine, negative cosine. The way I drew it, you guys said sine, so the way I drew it was positive sine, because that was just the easiest thing to do. That's pretty easy, isn't it? Really, I think graphing is the hard part with phase shifts and B values and things like that. What we did in yesterday's notes. So actual word problems, here we go. Harmonic motion. The wheel of a large Ferris wheel has a radius of 50 meters. That Ferris wheel is like 30 stories tall. It's a big Ferris wheel. It's 300 feet tall-ish. It's actually more than 300 feet tall. We have a large Ferris wheel, radius of 50 meters, rotates at 1 revolution every 30 minutes. That's really slow. This is one of those sightseeing Ferris wheels that they have in London and stuff like that. Okay. A seat starts at the lowest point. That makes sense because you got to get in it. So a seat starts at the lowest point, and your height at that time is only 1 meter above the ground. A little bit more than 3 feet. So you got to pop up into that. Maybe there's a step or something. I don't know. The question says to find sine and cosine functions that model our height with respect to time. You know what makes a question like this much easier? Drawing a picture. And a picture is not drawn to scale. But here is my Ferris wheel. And here is the ground. Here is the center of my Ferris wheel. And I know that the radius is 50. And I know that the height above ground is 1. That's my minimum height. What's the maximum height? The radius is 50. 101. Because there's 2 50-meter radii. 50 and 50 makes 100. Then what is the height here in the middle? 51, yeah. Because, 51, picture not drawn to scale. Let's get a sketch of this graph. We know this thing's minimum is 1. We know its maximum is a 101. We know its middle, midline, how about that, is 51. What's the amplitude then? 50. No, 50. How about that? The amplitude is the same as the length of the radius. That is always going to be the case. Always. What? Why is that? Because the radius is going to be how far down from the center and how far up from the center you can go in the circle. And that's why. So the radius of these word problems will always be your amplitude. We can safely assume that when we get on this thing, that's at time equals 0. And we know that it's going to take a full 30 minutes to finish this ride. That means this Ferris wheel begins at a minimum. And which of our shapes begins at a minimum? Which cosine? Negative cosine. Just like this one. Beginning at a minimum fits a negative cosine model. So if it begins at 1, it ends at 1. Halfway through the ride, you better be at the maximum. And halfway between a minimum and a maximum is where you will always find your midline. And then we try to connect the dots as best we can in the shape of a bell. Close enough. There. The only thing we need, yes? Yeah? Oh, if that's a homework question, if the answer was cosine inverse, because that's what arc means, you must have been solving for a time or an angle or something like that. Because when we write our equation, it's going to be h of t equals, and somewhere in here we're going to have a cosine function, and time is the input. So if you were solving for a time given a height by hand, you would have to use cosine inverse to get the cosine to go away. The only thing we need to finish writing this equation, since we do know the midline and we do know the amplitude and we know that it's negative cosine, and since we're calling it negative cosine, we could say there's no phase shift. The only thing we need is whatever b equals. And the period length is supposed to be 2 pi over b. Our period length is 30. So switching these two, multiplying by b and then dividing by 30, gives us 2 pi over 30, which is pi over 15. We are ready to write this equation. The low-hanging fruit, negative cosine wave, because that's what it looks like. H of t, where h is height in meters and t is time in minutes, is negative, because you said negative cosine. Amplitude, we said was 50, because that's the distance from 51 to 101. Cosine of, there's no phase shift, so it's just going to be this b value in front of t. And then the midline, there it is. The directions were defined. Yes? Phase shift is both the sine and cosine waves are supposed to begin at the y-axis, meaning that's where its period begins. So if your wave is not starting on the y-axis, then there's a phase shift. For example, the directions were to write this thing as both cosine and sine. There's no way for us to write this as a sine model without phase shifting it, because sine begins at its midline. Positive sign begins at the midline and goes up. So if you were going to give me a positive sine model, what value for t would I have to use for this one to begin at the midline and go up? Which of these t values has my graph at the midline and then going up afterwards? 7.5. So if we begin here, we can say we have a positive sine wave that has been phase shifted 7.5 units to the right. That's what a phase shift is. So we can also say h of t equals positive 50 sine of pi over 15 is still there, but we now have t minus 7.5 to shift it 7.5 to the right. And again, that is but two of an infinite number of correct answers for that word problem. Legitimately, as long as you draw the picture and plot a couple points, connect those dots, you should be able to see exactly what the equation is. This will be the hard part, the quote-unquote hard part, solving for b. How do you feel about that? Okay, remember, the radius will always be the amplitude, and whatever the height of the center of your circle is, that will always be your midline, because it'll always be halfway between the maximum and the minimum. Okay. This last question, don't write too large. There's a lot going on here. On July 4th, high tide occurred at 9:36 a.m. At that time, the water at the end of a pier was 2.7 meters deep. Low tide happened to occur at 3:48 p.m. At that time, the water was 2.1 meters deep. We're going to assume that the depth of the water is a sinusoidal function over time with a period length of half of a lunar day, so period length of 12 hours, 24 minutes. Let me tell you the number one issue with this question. The minutes. We need those minutes as fractions of hours. 9:36 is not 9.36. because there's only 60 minutes in an hour, not 100. So we need to convert all of our times into decimals of hours, and I strongly suggest what we call military time. I suggest we talk about the number of hours after midnight. So this 3 would be 15 hours after midnight. So this would be 1548, but we need to know what that 48 is as a fraction of an hour. So we need this 36 as a fraction of an hour, this 48 as a fraction of an hour, and this 24 as a fraction of an hour. And the way we make them fractions of hours is we legitimately just put them over 60 and then get a decimal. So I'll start there. Actually, I do it up here. I got a little bit of space up here. So 36 over 60, that's 0.6. 48 over 60, that's 0.8. Yeah, 48 minutes. And then this 24 over 60 is half of 48, so it's 0.4. What? What seems to be the problem? Those are just the decimals of our times. So the times that we're working with here, 9.6, 15.8, and a period length of 12.4. Does all that make sense? You know what? I think we need a picture. We need a picture, okay? The first time we know about happens to be 9:36, which is 9.6 hours after midnight. Picture not drawn to scale. We know we have a low tide, high tide? High tide there. High tide of 2.7. We then know that there is a low tide at 15, because 12 plus 3, 15.8. Low tide of 2.1. Is it 2.1? Yeah, 2.1. So if this is high tide and this is low tide, how much of the period is that? Half. So a minimum to a maximum will always be exactly half of a period length. Well, how long is a half a period? Remember, a period is 12.4 hours. So this is 6.2 hours. So if you want to know when it's going to be high tide again, you just add another 6.2 to that. 15.8 plus 6.2 is exactly 22. Which is 10 o'clock at night. 10 hours after noon, literally. Well, that's because we're saying that the period length is 12.4 hours. So from maximum to minimum had better be the same as minimum to maximum. And then halfway between those, every 3.1 hours, we have our midline, right? Nobody said yes, but yes. 3.1 hours will be your midline. Picture not drawn to scale. This is not halfway between 0 and 9.6. Picture not drawn to scale. And what is the y value of my midline? It is 2.4 because it's the average. The average of 1 and 7 is 4, so 2.4. I think we're ready to write an equation. Part A, write an equation. The way that we've drawn it, the way that we have drawn it. Positive or negative and sine or cosine? Positive cosine, because positive cosine begins at a maximum. What is our amplitude? What is it? Yep. So we have an amplitude of 0.3. We've already said that our midline is 2.4. We know the period length. We don't know B. We need to figure out what B is. Also, this positive cosine wave has been phase shifted. It should have started on the y-axis, but it didn't. It's been shifted 9.6 units to the right, because that maximum should have been on the y-axis. Let's solve for B. 2 pi over B is the length of our period, and the length of our period is 12.4. Multiplied by B divided by 12.4. You get that B equals 2 pi over 12.4, and you might as well reduce that to pi over 6.2. We are ready for the depth of the water with respect to time, where time is a number of hours after midnight. The depth of our water is, we said positive cosine, amplitude of 0.3. Yes, this cosine wave has been phase shifted. Specifically, 9.6 units to the right. And the midline's at 2.4. There you go. That is a model for this situation, not the A. Yes, and it was answer A as well. Now part B. Part B says, at what time was the first low tide? You can't assume that 348 was the first low tide. So how could we find the first low tide? So you guys said pretty much the same thing, you just said it in different ways. Which one of you said half a period behind 9.6? And then I think he said 6.2 less than 9.6. Either way, it's the same answer. So we're just going to do 9.6 minus 6.2 to get down to over here, because we know the distance between minimum and maximum is 6.2. So if we just go 6.2 to the left, we can say low time is 9.6 minus 6.2, which is what, 3.4? No, we don't. It says at what time is it? Oh, we have to put it back into hours, you mean? Yeah, well, we know that this is 3 hours after midnight, so 3 something in the morning, and it happens to end in a 0.4, which is right here. So it happens at 3:24 a.m. That's the first low tide. Part C. What was the approximate depth of the water at 6 a.m. and 3 p.m.? Well, we have to just plug those in. This is 6. This is 15. What'd you say? Xavier, you said something. Yeah, you legitimately just plug it in with a calculator. So you won't have a question like that on your test, because that's a little bit too tedious for me to ask you to plug in. That's more of a graphing calculator question. In fact, it's more of an IB level question. In fact, I'm pretty sure that this question came out of my IB textbook. So what you would do is you would just plug in t equals 6 and t equals 15. The depth at 6 in the morning is 0.3 cosine of pi over 6.2 times 6 minus 9.6. I'm not even going to simplify it. I'm going to type exactly what you see. And 3 p.m. is plugging in 15 because that's 3 after noon. The exact same setup, but instead of 6, you substitute in 15. And I would keep the calculator in radian mode because there was no mention of degrees. 0.3 cosine pi, by the way, pi is right there, divided by 6.2, 6 minus 9.6, close up the cosine and the phase shift, plus 2.4, looks to be about 2.32 meters. And one of the things that I really like about this calculator is I don't have to type all that out again. I can just scroll up, highlight it, hit enter. Then I can scroll left to where that 6 is, press the 1, but I'm not going to type a 5 because if I type a 5, it'll cover that minus sign up with a 5. So you second insert 5, then just enter one more time, and there's your answer. About 2.12. Remember, one of the things that I'm trying to do this year is teach you how to use your graphing technology. You might not be able to use it on the test, but I can't teach you how to use it for next year when you go to AP Calculus or College Calculus or IB Mathematics. And lastly, part D. What was the first time on the 4th of July when the water was 2.4 meters deep? What's significant about the number 2.4? It's the midline. It just wants to know, where is that going to happen? Yes, it's going to happen at 9.6 minus 3.1. Because the distance from max to midline is half of the half, or 3.1. So from here, plus 3.1, plus 3.1, plus 3.1, plus 3.1, or minus 3.1. So that time will be, and what were we looking for? What was the first time on July 4th? That time will be 9.6 minus 3.1, or 6.5. Did I do that math right? Okay. But wait a minute. It said the first time. So half a period back would actually be the first time. Why? She says why? Because this happened, let's see, where do we have a midline? Right here's a midline at halfway between this and this. So right here we have a midline happening at 12.7. So you could have done 12.7 minus 12.4 to get to 0.3. 0.3? What do you mean what just happened? Okay, all right, look, pay attention. Can we agree that right here is 2.4? Can we agree that that time is 12.7? Okay, what's 12.7 minus the period length? 12.7 minus 12.4? Or you could realize that you're going to be at this midline every half a period. Every half a period is 6.2. So because this number was bigger than 6.2, I subtracted 6.2 to find the absolute first time that would occur. So 0. What? The 6.5, when I got this answer, I realized that that wasn't the first time. That is a midline hit, but it wasn't the first one. Because it was bigger than 6.2, I could subtract 6.2 from it. So the very first time would have been 0.3, and then a midline hit happens every 6.2 hours after that. And that 0.3 happens to be half of this 0.6. So half of this 36, that's 18 minutes. So that is at 12:18 a.m. Was that going to be a question, Lucy? Okay, what's the question? Oh, remember, picture not drawn to scale for here to here. Well, so what I did was I did 9.6 minus 3.1, because that's a quarter of the period. That got me to 6.5. But I'm aware that if I'm on the midline, I'm going to be on the midline again every half a period. And since half the period was 6.2, and this number was bigger than 6.2, this wasn't the first time I was on the midline. The question says the first time. So I had to subtract 6.2 again. If this number had been 6.1, that would have been the first time. But because this number was bigger than 6.2, we did have to subtract one more time. Okay, and there you go. Word problems. Yay!